Thank you. All right, let's get started. And I apologize for my voice getting over a little cold. All right, so a little bit about myself. My name is Martin. I work at Red Hat. I've been on the product security team at Red Hat for about 13 years. And today we're going to talk about open source software identification. Quick agenda. We're going to talk about what software identity actually means. Then we're going to look at some of the standardized formats that try to solve the problem of identifying software. We're going to look at the usage in the available data sets that we have today. So like the CVE records data set and OSV. And then we're going to discuss some issues that come with software identity. And then we're going to have probably plenty of time for Q&A because I think this was a 60-minute talk, but I think I have like 30 minutes of slides, so we'll see. So when we talk about software identity, what does that actually mean? Essentially, we're trying to identify a set of attributes that we can assign to something to be able to identify it within its broader ecosystem. And the broader ecosystem here is doing a lot of hand waving because essentially we care about the topic of identity within a specific scope, right? So for us, it's most likely vulnerability management. So a lot of the stuff that we're going to talk about is software identity in the context of CVEs and advisories and security data, right? So other software identity schemes probably exist and they have their own purposes, but what we are going to talk about today is the ones that are fit specifically into our ecosystem. So if you have the identity of something, what is the minimal requirement for that identity? So you must be able to easily retrieve it, right? So if you're observing a thing, you should be really quickly be able to tell what it is and determine its identity. And then you want to do something with that identity, right? So you must have a set of tools that support understanding that piece of identity. If we think of like some of the simpler solutions of how can you identify a thing, anything, right? The first thing that comes to mind is model and serial numbers, right? You can just assign a number to something and that's it, right? So why don't we do that? Well, it would probably require some sort of central databases and it requires a lot of upkeep, right? Every time you release something, you have to give it a new number and everybody has to be made aware of that number. And essentially it becomes a nightmare in tracking numbers all over the place. And then migrations are difficult. It just comes with a lot of headaches. Alternatively, we could do hashes, right? So you hash an artifact, it produces a unique value, and that value is reproducible anytime anybody else hashes the thing. But that also requires that the thing that you're hashing is the same thing every time, right? So it requires reproducibility of those artifacts. And also hashes, similar to some serial numbers, are kind of difficult to compare. We could also consider URLs, right? If you host something on your website and that is its identity, you could use the URL to just point to it and, that is the thing. But URLs, domains change. And then there's really not really a standardized URL format for the identity attributes that we require. So if I call my package something .txt and somebody calls it .xml, those are two different things. So because we need something, there's standardized things that have been created by the industry that solve this issue. The first one, probably the oldest one, is called CPE. It was developed by NIST. I think it's around 20 years. I couldn't actually find like the first CPE 1.0 release anywhere. So I think like the earliest signs of CPE emerge around the year 2007. And it's one of the oldest standards for trying to identify something. Initially, it was mostly around identifying products. It has evolved to its latest version 2.3, and it's used by NVD. It's now used quite heavily in the CV dataset, and it has support within the open source ecosystem in some tools. The newer contender here is purl, which is a community-led standard, although it's not really standard, I guess a initiative. It's pretty widely adopted in the open source ecosystem. The first specification was published in 2017. I looked that up in Git, so maybe trusting the Git log, I guess, for that one. And then the other two that I'll just mention here, but we won't really cover them in today's talk, are Omnivore, which for the purposes of vulnerability management, I find it a little bit too complex. This is not to knock on Omnivore. It's a great concept, but identifying vulnerability metadata and pinning it to individual artifacts feels a little bit too fine-grained. But nevertheless, it exists, and I would love to see some use cases for it and to prove it out. And then we have SWID, which is another NIST-developed standard that I have not seen widely adopted really anywhere. And even the documentation is hidden behind some ISO standards, so we're just not going to talk about it. So let's talk about Perl first. Perl stands for package URL, and it's a standardized approach to identifying and locating software artifacts. So it's essentially a single identifier that consists of 7 different attributes that have specific meaning and specific values that give you enough attributes about the thing that you're trying to identify to be able to identify it and locate it. It follows the URL syntax. So every Perl is actually a valid URL as well. This comes with a couple of downsides. And here we can see some examples. So the first one is the identity of a package, a Debian package that was created in the Debian namespace called curl. It has a version, and then it has a couple of qualifiers that essentially give you extra data about that component. So this one says that it was specifically the package is built for the i386 architecture, and it was shipped as part of the Jessie Debian distribution. Another example is a Python package called Django. PyPI is one of the allowed Perl types that essentially define where the package lives. So PyPI is the Python package index, and implicitly you would know that such a package would be treated within the scope of the Python package index. And the third one is yet another package type for Golang, for Go modules that identifies the namespace, the name of the component, and then the subpath actually specifies it within a specific module within the genproto package itself. So Perl is pretty widely adopted in a lot of tools. Sift supports it, which is an SCA solution. Guac, which is a graph-based solution for showing dependencies, supports it. There's a variety of commercial solutions that also support parsing Perls out of SBOMs and CSAF files. And then a lot of the standards also are able to grok it. The CVE v5 schema has a little asterisk in it, and we'll talk about that later. So when we talk about Perl, I read this really nice analogy of how you can compare Perls to actual mailing addresses. And I think it's a pretty decent comparison. So a mailing address can be very specific. You can have, for example, an address that points to a specific street and a house number within a city. And that essentially identifies maybe a component within a particular ecosystem with its name and a version, right? Then you can go a little bit more fine-grained, and you can identify a specific file name, just like you would identify somebody who you want to mail a letter to. And then for things that are not well defined, so somebody who lives in a very remote area, they won't have a really full mailing address. They may just live in some village 123, right? So for those, we can always revert back to some like generic identifiers and point to the place where you can download the thing. And then absolute worst case, you can create an identifier that just has a checksum that tells you like, this is it. This is all I know about the thing, and it's a fully well-structured identifier. Let's talk about some of the downsides of Perl. This is just an example one, but as you may have noticed already, Perl is mostly based around identifying packages within specific ecosystems. And because those are packaged types of software, it's less, it requires that the package is actually defined under a specific type within the Perl specification. Adding new types is relatively easy, but comes with some downsides of having some types, being deprecated and new ones added is a little bit painful. Then because every Perl is also a valid URL, all of the contents of the Perl have to be encoded. So if you have any values, for example, in this one, I purposefully didn't encode it, but the colon in here technically should be % encoded, because otherwise this would be treated in a different way as a URL. And the character encoding makes the Perls not look great. I have some examples later. And it's also a pain point for the people who write the tools that parse and generate these strings to do it consistently every time. And then because this is a pretty new standard, there's quite a bit of undefined behavior within the specification. For example, the architecture values and the distribution values are not really defined. The qualifiers for them are recommended, but it's not clear what the values of those qualifiers should be. And anytime you leave something open for interpretation, people put random crap in there, and then it looks bad. The namespace values, same story. I've seen both of these, for example, used, and they essentially mean the same thing, but there is no standardization that says what is a namespace and how should you use it. Similarly, all of the different package types have their own rules about each of the different fields, and some of them are a little bit duplicative of each other. For example, the Debian package tells you to use the epoch, which is a part of the version string, directly in the version field, whereas for RPMs, which is just another type of package for another Linux distribution, the epoch is its own qualifier. So it would say epoch equals 1, for example, which is a little bit inconsistent. So there's a lot of grunt work that still needs to happen in the Perl specification to make it like fully featured, but we'll get there. And then I already mentioned the difficulty about adding new package types. It comes with a lot of heated discussions in the repository often. So far we've looked at how to identify a specific component within a specific version, but there's often a need to specify version ranges. So specifically for CVEs, we always care about pinpointing vulnerable versions. Something is introduced in version 1, fixed in version 3, and version 4 and later are not affected. So Perl has its own substandard or sub-specification within it called version range specifier, verse, that has a pretty minimal way to define version ranges as either just a list or version ranges that start and end at a certain version number. Each version specifier also tells you how you should be able to compare the individual versions. So for example, Python packages have a very specific way of how to compare these versions. But since you know that because of the string that is used here, you know how to compare these, right? Because we have many, many naming schemes and they all get compared in weird ways. And if you marry these two together, the verse specifier essentially gets put into the Perl as its own qualifier. So you can still identify the package itself, and then you identify its version ranges within a specific qualifier. And here you can see that this is the unencoded version of the Perl, and this is the encoded one. This is what it actually should be when it's stored in data. But for humans, this is a lot less readable than this, obviously. But that's, that's a UI problem, not a data problem. So a human, if they need to see a Perl, it could be decoded like this or presented as separate fields. But in the database, when you're storing this data, it should always be encoded. All right, let's take a look at the second contender. But before I continue, Has anybody used purls before? Excellent. A lot of people. All right, so let's take a look at CPEs. CPEs, much like purls, are used for identifying things like IT systems, software, packages. It's a pretty widely open schema. It allows for identifying really anything as long as it fits into one of these specific attributes. So the version 2.2 had less of them. Version 2.3 has more of them. Both required certain elements as mandatory to have like a minimal set. The spaces around are just so that we can read this better, but a full CPE has them removed. But there's really not really any guidance on how you should be using the individual fields. There's guidance into what the values mean, but not really guidance about what you should put in there. So these are some examples of valid CPEs from the CVE dataset. Here we can see that the first one identifies OpenSSL in its version, doesn't really use any of the previous attributes. I think the last one is target hardware, right? So this is probably the architecture that Windows server is running on that we want to make specific for this particular identity. And then GitLab Enterprise is a software edition, probably. So it allows you to pinpoint a more specific variant of the thing that you're identifying. It doesn't do, of course, the job of locating the artifact, only creating its identity. So this is not like Perl, where you can use a Perl to technically also download the package if you're given its Perl identity. These are nice examples. These are less nice, and these are actually from the CV dataset that somebody created. Not sure who, but I'm sure they have their own use cases and they're probably valid, but I found them funny. The first one, I would argue that something went wrong there, probably. So some downsides for CPEs. CPEs, I'll start from the bottom. CPEs are technically supposed to be used as part of this central data set that is maintained as the CPE dictionary by NIST. But in reality, I think everybody just mints their own CPEs, as we can tell over here, right? And those just make it into the dictionary without much review, right? So if I decide I want to create my own CPE, I put it in the CV record and it's collecting into the central CPE dictionary, and then it's the source of truth. I don't know that there's any review mechanism that tries to resolve issues like the one we see here, where we have multiple CPEs that essentially identify the same thing, but they're all over the place. And then I would say that CPEs are not as widely adopted in the tools that exist in the open source ecosystem for specifically generating and handling the identity strings. Definitely much less than Perl. Perl has a lot of libraries that are able in variety of languages that are able to generate it, process it, and store it in a database, whereas I haven't seen as much of that for CPE. Again, with Perls identify a single component, and then there's the verse specifier to identify version ranges. CPEs kind of have the same thing. CPEs allow you to identify a specific version, but there's these special statements that were originally added into the CV records by NIST that allow you to specify ranges of versions. In the NIST data set, they were called CP configurations. And they actually, I feel like they try to replicate a little bit more the composition of the software. So they allow you to specify a component and then its dependencies. So for example, if you're trying to identify a component and make it specific that it runs on the Linux kernel 123, then you can express that in a very specific CPE configuration. I feel like that a little bit replicates what SBOMs do, but oh well. Anyway, the CP applicability statements allow you to define ranges, mark them as vulnerable or not vulnerable. I think there was a presentation yesterday on this topic. So if you missed that one, I recommend watching it. And then the CVE program recently published a quick start guide on how to use the CP applicability statements. But we'll see some examples of them shortly. And I also mentioned this, that the two formats, obviously, they're not really transferable to each other, but there is some sort of an effort to convert purls into CPEs and vice versa. There's a data set that tries to publish this data for any found purl in the wild or any found CPE. The data set is open, but I'm not sure how it is created. So if somebody from CNAs is here, maybe they could enlighten us. Anyway, so let's talk about what these software identity schemes look like in practice. Where are they actually used, right? The first place is obviously CVE records. CVE records have their own affected object, which identifies something and then identifies the version that is vulnerable to a CVE. And recently, the CP applicability statements were added as a supported way to identify software within the CVE record. Some of it, to me, is replicating the Perl and verse way of identifying this, but that's okay. CVE records could support any number of ways to identify things as long as they're kind of interoperable between each other. If you look at the data set, CP applicability statements are really only used by Microsoft and MITRE today. I haven't really seen any other CNAs use them. And then Perl, on the other hand, is not really used at all within the CVE record dataset. And that's mostly because the Perl usage within CVE records is not well defined. There is support for it. You can put a Perl into any field that is supposed to give you information about a version, but that's not proper Perl support as other specifications usually have it. So this is what an affected object looks like in a CVE record. This uses the old way of specifying an array of CPEs, which was found to be not sufficient enough, and that's why the CPE applicability statement was added. And the affected object essentially allows you to define ranges of versions, and then for each version range, you can tell what is affected, what isn't affected, and then the vendor and product values are not really defined well and not standardized. So they're mostly up to the CNA to provide. Question for the audience: do you see any mistakes in how these versions are specified here? This was, I think, taken from one of CISA's enriched records for this particular vulnerability. Less than what? Mm-hmm. Yeah. The issue here is, first of all, the version type should just be semantic versioning. Django uses semantic versioning, and this is not a valid version. It should be 5.1.0, right? Because there is no such thing as 5.1. So that's a first like nitpick. And then for the version range that starts with 5.1.0 and goes all the way up to 5.1.4, we're defining that that is the affected range. So the vulnerability affects anything from 5.1.0 to 5.1.4. And that's all the information we have for that range. And then we have two other objects that essentially give us the same information, but for different version ranges. So we know what's affected. Well, what about the rest? Unknown. So technically, we have the information in here that 5.1.4 is the last version or technically it's the version that is fixed, but nowhere is it explicitly stated. So these are just minor details of why it matters to have this data to be accurate, because if you write a program that parses this data and makes determinations of are you affected or not, parsing this is not going to tell the program much. All right. It's just going to identify what is affected, but then it's not going to tell you what is not affected unless you make assumptions, which we don't want to do. This is one of the few usages of Perl within the CV dataset. So in the version specific fields, you can actually put a Perl in here. But I think there's less than 10 records that do this, and it's not documented well. So I think we need better support for Perl within the CV record. I think there's an outstanding issue in the CV schema. It just needs to be actually worked on. And this is an example of the CP applicability statement that was recently added to the CV schema that allows you to essentially identify something and then identify the version ranges that something is applicable to, right? So in this one, this is a very easy one because it's just one statement that says anything that starts with this version and ends with this version, excluding that version, is vulnerable. I also looked at what is the most used CPE in all of the CV records, and this is the top 10 list. So I'm not sure what this is actually useful for, but it's interesting to see that Qualcomm is a very heavy user of very consistent CPEs, and apparently there's a lot of CVEs in their firmware. And the Linux kernel, that's a big one. Let's take another look. Let's take a look at another data set where software identity can be found, which is OSV. OSV is another database of vulnerabilities. It's actually an aggregator. So vulnerabilities are aggregated from different sources into OSV. They're parsed and they're kind of made into one cohesive data set. The OSV schema gives you a way to represent vulnerable ranges as well. It has its own affected object that defines the identity of the package that that is affected. And then it does support Perl. It has an optional attribute for specifying the Perl of a given component. The data in OSV is of relatively good quality because it's programmatically created, right? So it's hoovered up from various other sources and it's processed, and there's some smart ways to make it a cohesive data set with proper version numbers. All right, so this is an example of a Go module and its version ranges. It's very similar to what we've seen with the other ways to specify ranges. Essentially, you're always trying to pinpoint the version that introduced something and a version that fixed something, and that defines anything in between as well. Here we can see the optional Perl attribute that allows you to use a Perl for the name of the component, right? So this is not going to contain the version because obviously you want to use the ranges to give you the information about the version ranges instead of pinpointing one specific version in the Perl itself. I'll just quickly mention how Red Hat is approaching software identification. In the old days, it used to be really easy because Red Hat was primarily a Linux distribution company, and our Linux distro shipped RPMs, and RPMs are really easy to identify because they have a naming scheme called NEVRA, name, epoch, version, release, architecture, and that gives you essentially all the information you need about a particular RPM. Nowadays, things are a little bit more complicated. Red Hat has about 200 plus products from all sorts of language ecosystems, all sorts of packaging mechanisms, container images, RPMs, RPM modules. And so things get a little bit more complicated. This is when we need to start thinking about how do we differentiate between a lot of these components. So you can have a Python package that has the same name as an RPM module. We need to be able to tell them apart. We do use CPE but we use it kind of in a weird way. We only use it for identifying specific products. So we use it as a product identifier, not a component identifier. We have all CPEs in a single data set that is centrally maintained, and we issue CPEs per product release. And then we use purls for components. So to identify a specific component that is shipped within a product, we generate a purl. We always namespace it to Red Hat to identify that it was built by Red Hat. And then we pinpoint some additional attributes that make identifying that component easier in all of our security data, essentially. And then because Perl is a little bit ambiguous when it comes to the values of certain fields, we actually published a set of guidelines that detail this is how we use Perl. You know, this is if you see this in a Perl, it means this. If you see this type, it means this, which makes it a little bit easier to then have a single way to generate Perls, because Perls are a defined identifier. And so if you define it in the same way that I do, then that's the intended purpose, right? So that we can create the same identity for the thing that we're looking at. Let's talk about some of the challenges that we have with software identification. One is just knowing how to relate different components to each other. So if we take a look at something like Django, which is a Python web framework, the first 3 purls identify essentially the same thing, except this is the Python package that is hosted on the Python package index that ships Django in a particular version. This is the website where you can download the same source code that is present in the Python package index. And this is the GitHub release that also contains the same source code, right? So these 3 things are essentially the same thing. And then to make it even worse, those things usually are shipped as part of some Linux distributions or other products, right? It doesn't have to be Linux distros. And in there, they take on a different name, different versioning scheme, and they have some additional attributes, and they're namespaced to the specific entity that actually built them, right? So how can we essentially relate all of these together? I don't think this is a problem of the identity specifically. It's mostly about relationships between these components, right? Defining how they relate to each other. And for that, we have another great standard, SBOM, right? So if the Python maintainer decides that they want to support all of these 3 identities as the thing that they're shipping, they can create an SBOM that claims all 3 of those. If Debian decides to ship Python 3 Django, which is based on the PyPI package, then they can release an SBOM that claims both of those, and it has a relationship between those 2 packages that one is a descendant of the other, or an ancestor, I guess. Another challenge is identifying the loose things, like the things that are in the remote areas, right? So how do we identify C and C++ components that just live on random websites? They don't really have a way to authoritatively claim what they are. We just have to agree as an industry to, you know, call it the same thing. I don't really see any other solution than just having like a central list of these dependencies and give them a unique name and then use that across the entire data set. In the CVE records, the OpenSSL CVE records just use a product of OpenSSL and vendor OpenSSL. Great. But let's make sure that's a standardized value and use the same for any other CVE records for OpenSSL, right? If the next one says OpenSSL dash something, then we have a messy data set already. And then the third one is just improvements in the ecosystem themselves. The accuracy of this data matters because it essentially ties the one thing that the CVE is related to, which is the thing that is vulnerable, right? All of the other metadata like CVSS and CWE and EPSS, they're additional data that are tied to the tuple of a CV ID and the thing that is affected, right? And if we can't have information that is accurate enough to determine that thing, then we lose a lot of the other benefits of the other additional metadata as well. I mean, at VolnCon last year, we talked about this, and it's a year later, and I don't think much has improved. So the CVE record supports more way to identify things, but there's still no requirement on CNAs to do it accurately or actually do it in a way that allows for better downstream use cases, right? So how can we motivate the CNAs to do this? And I know it's probably a lot of work, but there are ways to approach that with outreach, training. We can help the CNAs to improve the data set. And then once we actually submit good data, it should actually be trivial to convert between the different formats because I think they should be interoperable, right? So if I submit purls, there is no reason that those can't become CPEs in the backend CV record. And if I care about consuming CPEs, then I look at that data. If you are a user of Perl, the specification needs a lot of love. There's a lot of issues and open PRs on GitHub. So I urge you to go and help out because I think the project is drowning in open issues that need to be resolved sooner rather than later to make it less complex rather than more complex. And then my last note in here is that if we actually nail down the accuracy of this data and allow others to contribute to the CV records themselves through the ADP program, we can have a much more cohesive data set that is able to point to an upstream component and then identify all of its downstream variants, right? So if I, as an ADP acting on behalf of Red Hat, can add my information about Red Hat specific RPMs to something that was released by the curl CNA, then the link exists from the upstream curl to the curl RPM within a Red Hat product, right? If every CNA does this, then we have a single source of truth that tells you everything you need to know about the vulnerability and its downstream effectiveness, not just the upstream one. And with that, I'll close it out for questions and hopefully some discussion.
Thank you very much, Martin, for that. I realize we are a packed house, so I will try my best to either toss the microphone. I'm not throwing it, but try to get the microphone to you. Is there any questions at this time that we can help engage answers on? Oh, hey, just tap me on the shoulder. There you go.
Yeah, hi, thank you for your talk. Amazing. Also, thank you for asking for CNAs to push their data into upstream containers. My question would be, after talking about those different namings and standards, how does Red Hat approach kind of a mapping between those standards and to make sure that kind of we talk about the equal thing? So this Perl is equal to that CPE, or basically that Perl is some subset of that CPE. Is there anything that you can say on that regard?
So speaking at the component identification, we haven't really tried to make it interoperable with CPE specifically, CPE 2.3. But now that CPE applicability is supported in the CV records, I think we have some exploration to do of how we can convert our pearls into the CPE applicability statements so that we publish the same data, right? I don't think it should be difficult. The Perl, I think, has more data than CPE, so I think it's going to be easier to convert pearls to CPEs rather than the other way around. A CPE does not have enough information to make a full Perl in most cases, I think. So I think the other part might be more difficult. But we're starting with pearls, so it gets a little bit easier. Andrew.
Okay. Is it on? No?
Yeah.
Okay, I'll go and then you. Unfortunately, I got a lot of questions for you, Martin.
Okay.
And unfortunately, yes, he works for me. But I want to kind of up level instead of from a Red Hat perspective, from an ecosystem perspective. You know, you talked about how we do a standard in a standard namespace. So I started with the namespace because it was like you almost have to have that to work. Are you thinking that the CVE program should kind of help push this through? And you put something there about first class citizens. So it intimated like a tiering of those who could do it and then ADP for those who can't.
No, that was a call out to like proper support for purls within the CVE schema, right? We need to be able to have have a custom or have a specific object that has purls. Just like we have the CPE applicability object, there needs to be a purl object that supports purls and purl and version ranges, and you know, rather than it just being something that you put in the version field.
Okay, and I'll ask this a second one. The S-bomb part, you caught my attention. Are you? Yeah, unfortunately, he's my S-bomb guy. How are you looking for us to refer that? Are you looking then that, I mean, how do I know what's a good S-bomb that you could refer to? You know, what's your idea how we approach that?
Right. So it depends where you are referring from, right? So if you're publishing a VEX file, that VEX file can refer to a single component, right? But maybe I want to give you the information where that component came from. Maybe it's, 3 layers of upstream, but I would hope that you don't put that in the VEX file. You can just refer to the SBOM that shows you that full picture and say, this is the affected component, and here's an SBOM that shows you its provenance. And then the SBOM itself shows you the entire path from the rel RPM that contains Django all the way to the upstream Django source project, right? The references could just be like a pointer at the SBOM, right? Like here it is.
Okay. So Perl talks about distributed model, right? So the developers can put the Perl into their packages.
Yeah.
But this introduces a big problem because developer can do whatever they want, even they get a training. So for the same like Django versions, they could put 10 or 20 different names. So this is the alias problem we were already been facing, even for the centralized CPEs. So for example, Red Hat has their namings, Oracle has their own, Microsoft their own.
Yeah.
You create big problem, right? So how can I identify the same version, same thing?
Yeah, that's this slide.
Probably
right?
can rely on AI to do some, identification, but
there's always going to be multiple identities, right?
So
and we just have to be able to define the relationship between them.
Yeah, I don't see any solution unless we have centralized one.
It being everyone then to publish where they have their identity listed, right?
I mean, that's how the CPE dictionary is supposed to work, right? It's supposed to be a central data set. And here we are. Yeah. I don't know. The central model also has its downsides, so.
Awesome presentation. Thank you. You were very humble and you failed to shout out your own CNA lint tool, which CVE lint, sorry, tool, which is awesome. Thank you. There's a lot of opportunity there to have extra contributed checks. I think that the data that spits out is really, really helpful for doing data-driven decision makings around how we can up-level standards enforcement for minimum standards for CVEs. And a shout out to Jerry for running a daily analysis of that. So really awesome, both of you. Thank you.
And Jerry had the same message yesterday. I was at a SOC and I don't know where he is, but if he's here, that like we need to be able to enforce some of these standards because it's producing a lot of bad data. And then there's a lot of products that work on top of that data and produce a lot of false positives, right? So,
and negatives.
right? So if you solve the identity it covers like 90% of those false positives and negatives.
Yeah, I think especially for the previous slide that you had up, it's important to notice that those are in fact different things. They have a relationship, but that relationship is it's not the same thing. If I get my package from Debian, that might be different than, or that is different than the one that I get from Fedora.
Yeah.
One might have a vulnerability just because of the timing and how they compile it.
Yeah.
The other one doesn't have it.
Yeah.
So
That-
things that are distributed to different channels are different things.
Mhm.
Those are not the same thing. They have a relationship. We need to cover those things. But those are not the same thing.
Yeah, they're not the same thing. I would argue that the first three are the same thing. Would you argue with that? Technically, but if you're on PyPy, there's probably some extra cruft in the package itself that isn't maybe present or is present in the source repository. I think what you're saying. True, but then if I go back to my definition of software identity, it's like within a specific ecosystem, right? So for the ecosystem that we're in, vulnerability management, I don't care if it's a one-to-one binary match of all files, right? I care about the vulnerabilities. So if the vulnerability, it's very unlikely, sure, it may be, that you will have a vulnerability in the PyPI package and not have it in the GitHub release, right? Would you agree with that? Yes. 1 in a million. But regardless of if you consider these to be unique or not, the downstream versions of them need to have that extra context of how they're related to each other. And that's why you will always see vex statements for probably this and a separate one for this, right? Because you need to, it's essentially becomes a different statement of effectiveness just because it's a different thing, but it's based on the first thing, right? So you need to have the context to be able to relate those two together, which an SBOM is, I think, a good delivery mechanism for that.
So I'm trying to figure out if you've actually answered the answer to this challenge or not. And I asked the same question in the GitHub or in the Discord channel was, do you have a solution for tracking these relationships within Perl itself?
Not Perl.
Not
Because
Perl.
not Perl. So I've actually seen attempts to encode some of these relationships in Perl, and it would look like this, and then there would be a qualifier, and it would say like downstream equals this, right?
So your answer is the hierarchy within the SBOM itself
Yeah,
with the
yeah,
relationships.
Yeah. Like let's leave the hierarchy to the tools that actually are that were designed for that purpose, which is SBOMs, right? And so if you care about these relationships, then we need to get everyone to start publishing these SBOMs, right?
I can add a little bit of extra color to that, not from the SBOM angle, but from the OSV angle. We've just added upstream as a field to the schema. So you might have a vulnerability record in, say, in this instance, PyPy, and then you might have a Red Hat vulnerability identifier for the vulnerability in the artifact shipped from Red Hat. And there's a relationship expressed between those two. So you can say that rather than just having to have an alias or a related, we've now got an upstream as well. So that's another way to do it from the vulnerability scanning.
Yeah.
And
All right. At that point, I think we'll wrap this session up. One more round of applause. Thank you.
Thank you.